Hello grade 8s, this is lesson M5 on hydraulics and pneumatics. Now there are other videos that I would like you to watch with this, just as some examples, so please watch those as well. This is just a class notes video. So first of all, hydraulic systems use the forces of a liquid in a confined space. Right, so we're going to put in force of a liquid in a confined space. Now, this means that it is what we call a closed system. Liquid's not getting in or out, but we've got force acting upon that liquid. Now, hydraulics apply two characteristics of fluids. First of all, the incompressibility. And their ability to transmit pressure. Now, when we talk about incompressibility, what we talk about is the ability to withstand or not change volume when pressure is added. And if you've ever tried to, let's say, stand on a full pop can, you'll find that it's able to take that compression strength very, very well, simply out of the fact that the liquid inside is not compressible at all. If you had, let's say, an empty pop can and you stood on it, it would probably squish very easily. So the liquid inside there, that incompressibility of the fluid liquid inside. Now, pneumatic systems do not seal gas. Okay, usually air, as it passes from a place of high pressure and then escapes. Right, such as what we got in the empty pop can there. High pressure pneumatic systems may come from a machine that draws air from outside and compresses it. Compresses it. Okay, so if we take a look at some examples here, some examples of pneumatic devices might include things such as the jackhammer, an air gun, a dentist drill, or a sandblaster. Right, all of these use gases, and they all, this is all an open system. So it's not enclosed. We're trying to force the gas out. Hydraulics examples might include something like car brakes. We'll put car in front there. A backhoe, airplane wing, or steering wheel. Okay, so when we take a look at hydraulics and pneumatics in the body, we've got a couple of systems that we're looking at here. First of all, if you take a look at the pneumatic system in your body, it's more complex than any pneumatic machinery, and really what we're talking about here is the respiratory system. Oh, I got pneumatic system in your body. It's more complex than any mechanic. You know what? Probably it's best if we just, instead of doing that, what we'll do is we're going to put the respiratory system. Okay. Now, breathing depends on changes of pressure of the air, right? When we've got more pressure inside our body than outside, usually caused by a tightening of a relaxing of the muscles, decreasing the volume of air in our lungs, air comes out. When we tighten our muscles, our lungs expand, we've got less pressure in there, air flows in. Now, a complex hydraulic system in your body is the circulatory system. And this is blood pumping around the body. Now, hopefully, we understand that the respiratory system is open, right? Air comes in and out. The circulatory system is closed. We do not want blood going in or out. But unfortunately, sometimes it opens up, and that's usually not a good thing. Blood must be kept under pressure to be pumped through the body. Our heart is an actual amazing device, hydraulic device. Over a lifetime, it will pump nearly 4 billion times on average without stopping, and total circulates through it goes 500 million liters of fluid goes through the heart in a lifetime. Absolutely fantastic. Okay, throughout these systems, a lot of times valves and pumps will be used. A valve is really just a movable part that controls the flow of a fluid by opening or closing. Now, that fluid, again, can be liquid or gas. One of the easiest examples of this is when you blow up a balloon and you close your fingers. Your fingers wind up being the valve. And the tap is simply a pump in the water pipe. So what this might look like would be something like this. In this particular video, it's coming up. Waiting for it to load. So here we see inside the pipe, and it's coming up to a valve. Now the valve is closed at this moment, and it's opening up. How's that opening up? Well, what's actually happening there, it's actually a ball that gets rotated with that kind of almost Pac-Man opening. And so as it rotates one way or the other, we see that it will control the flow of the fluid, in this case, a liquid, but it could also be a gas. And this is just shelled within a much larger device. Okay. Now, many pumps are automatic, use an automatic valve control, which are basically controlled by pressure. On one side, if it's greater than the other side, will determine whether it will open or close. Okay, so if we take a look here at this other video here, we see that as we move up, we've got higher pressure inside here, higher pressure inside here, valves wind up closing. As we move down into stage 2, because we've got less pressure less pressure inside and more pressure underneath as we push this down, water comes in, the valves open up, and as we lift up, you're going to see that force of gravity cause it to go back down. But we've got more water now inside the tube of this particular valve pump. Okay, and so this cycle is going to continue. as we continue to move on, and water is actually then going to be coming out of the pump as we continue to go up and down between stages 3 and 4. Now your heart is basically 2 pumps which circulate the blood through the artery. The heart uses also 4 valves, 4 automatic valves, which circulate the blood, and blood pressure increases and decreases between beats. Okay, and that's it for the class notes portion of this section. Again, please watch the other videos as they do provide a much clearer picture of all that's going on. Thanks for watching and have a great day.